So in your matrices, it's an arrangement of rows and columns. In your rows and columns, you have to know what is your row matrix, column matrix, what is your diagonal matrix, square matrix, how to find out the order. Okay, all those things you'll have to know. And then we went into finding out your characteristic equation. Your characteristic equation for a 2 cross 2, what is your formula? What is your formula for a 2 cross 2? Will be lambda square minus S1 lambda plus S2 equal to 0. This is for a 2 cross 2 matrix. Okay. Yeah. So for a 2 cross 2, this will be your formula, where your S1 is equal to your sum of the main diagonal elements and S2 is your determinant of it. Okay. And then we have for a 3 cross 3 matrix, your formula will be lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. Okay, this is for your 3 cross.
ஏன்னா அந்த சமூகம் வந்து அப்படிதான் இது சார்ந்த கேள்விகள் எதுக்குமே எனக்கு பதில் கிடைக்கல. ஸோ நானும் இந்த மாதிரி பயந்துட்டு தான் இருந்தேன். என்னுடைய 14 வயசுல வந்து என்னுடைய ஹாக்கி கோச் திரு அந்தோனி சேவி அவங்க
I think I've given you the option to unmute yourself. Unless and otherwise you're going to talk something related with the subject. Otherwise, please mute yourself so that it is not a disturbance for the students while listening. Okay. And someone is making me spotlight. Okay. Why are you spotlighting me? One became the host. I will spotlight for you. I think everyone's able to see the board. Yes? Yes or no? You can tell yes or no now. Okay. Unless and otherwise, don't unmute it. So for a 2 cross 2 matrix, this will be a formula for finding out your characteristic equation. General format of your characteristic equation will be modulus of A minus lambda I equal to 0. Okay, that also you can formulate it, but you will have a lengthy procedure. Whereas when you do it in this formula, it will be easier compared with that formula. So for a 2 cross 2, this will be the formula. For a 3 cross 3, you'll start it from your lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. Your S1 is your sum of the main diagonal elements. S2 is your sum of the minus of the main diagonal elements. S3 is the determinant of it. Okay. Almost everyone had done correctly in your characteristic equation. Whoever had sent me the homework problems, I was very happy. But probably in the beginning, that is on Thursday, many of you had sent me. But on Friday, only probably maybe very few of you had sent me that Cayley-Hamilton theorem. Whatever it is to satisfy, isn't it? If whether it is satisfied or not, you'll have to prove it. I don't think many of you had done it. Please do it so that you will understand how this problem is carried out. Okay, this is a 16 marks question. So verify your Cayley-Hamilton theorem means what is your statement? Every square matrix, okay, whatever it is a square matrix. Okay, so every square matrix satisfies its own characteristic equation. It will satisfy its own characteristic equation. Your characteristic equation is nothing but this. Instead of this lambda, you will substitute A. Okay, A is nothing but the given matrix. Okay, so that given matrix, definitely it will satisfy if it is a square matrix. Okay, so every square matrix satisfies its own characteristic equation. That is the statement of your Cayley-Hamilton theorem, which is very, very important. Okay. In that, we had found out your verification of the Cayley-Hamilton theorem. Next, we will go on to A inverse and finding out your A power 4. Okay. So I don't think anyone's got this doubt in this characteristic equation and your verification of your Cayley-Hamilton theorem. I put today's date. Okay. So you have to know your Cayley-Hamilton theorem's statement. Your Cayley-Hamilton theorem statement is every square matrix. I'm repeating it again and again since it will be asked for 2 marks question. Okay, so every square matrix satisfies, you have to write this word satisfies. Okay, satisfies its own. Everything is very important. Satisfies its own characteristic equation. Okay, so characteristic equation, you know how to find out. For a 2 cross 2 equation means what? For a 3 cross 3 equation means what, you know. Okay, so your Cayley-Hamilton theorem statement is every square matrix satisfies its own characteristic equation. Okay, so in this, we will take off that first problem itself. We will find out your A inverse. We have not found out your A inverse, and in the same problem, we can find out your A power 4 also. Okay, so I will take out that first problem, that 3 cross 3 problem itself we will take. So your A was, your given matrix was 2 minus 1, 1, minus 1, 2 minus 1, 1 minus 1, 2. Okay, this was the given matrix. Okay, and you had found out your characteristic equation. Your characteristic equation was, what was your characteristic equation? Lambda cube minus 6 lambda square plus 9 lambda minus 4 equal to 0. Okay, this was your characteristic equation. So in that, they had asked you to verify your Cayley-Hamilton theorem, and everyone, we had verified your Cayley-Hamilton theorem. That is, you have to prove that a cube minus 6a square plus 9a minus 4I equal to 0. We will take this as the first equation. Okay, and we found out what is your a square. Your a square, you tell me the values. We had found out, no? Tell me the value of your a square. What was your values? A square. Take out your notebooks. Tell me what is your value of your a square. And you can unmute and tell. You got 6 minus 5, 5. And then minus 5, 6 minus 5, 5 minus 5, 6. Okay, I'm writing all these values so that to find out your A inverse, we need your A square, A cube. Okay, and your A given matrix is here. Identity matrix we know. Okay, what was your A cube? Your A cube is nothing but your A square dot A. We have already done this problem. So we have done this problem, isn't it? Why are you all very quiet? We have found out A cube. You're all very quiet. You can unmute if when I'm asking you questions. We have done this problem, isn't it? Yes or no?
Yes, ma'am.
Yeah, tell me the values of A cube. Tell me the values of A cube. What was the value of A cube you got? You had got 22 minus 21, 21 minus 21, 22 minus 21. Check whether you had got the same values. Okay, so this was the value of your A cube. Okay, and then what did you do? You substituted here and saw whether it is equal to 0. Okay, now you'll have to find out your A inverse and your A power 4 to find your A inverse. Now listen, then I will tell you. So we're going to find out your A inverse. So how do you find out this A inverse is? You'll multiply it in this first equation, that is your characteristic equation. You'll multiply it with A inverse. So when you multiply it with your A inverse, multiply your first equation by A inverse. A inverse is nothing but, what is your A inverse? What is your implication of A inverse? It is nothing but 1 by A. Your 1 by A is only written as A inverse. Okay, so I'm multiplying this first equation with your A inverse. So what do you get? When you multiply A cube into A inverse, it will become is A cube into 1 by A. So that will become A square. Okay, A square. Then minus 6A square into A inverse. You want me to do it here? I will do it. Okay, minus 6A square into A inverse. And then you've got plus 9A into A inverse minus 4I into A inverse, which is equal to 0. Now I'm multiplying it into A inverse, so which is nothing but your 1 by A. Your 1 by A, so when you multiply it with your A cube, that will become A square. Okay? And here 6A square into A inverse will become minus 6A. Okay? Plus 6, 9 into A inverse, it will become 1. Okay? So when it is 1, that it becomes a constant term. When it is a constant term, you take it as your identity matrix. Okay, so that will become 9I. Okay, minus identity matrix into A inverse will become A inverse. Okay, so minus 4A inverse equal to 0. Okay, now you want only A inverse, so all other terms you take it to the right hand side. So you keep your left hand side here, minus 4A inverse around this side. Okay, I'm taking all other terms that side, so it becomes minus A square. Otherwise, what you do, taking out this, we will take this 4A inverse alone that side. So it becomes A square minus 6A plus 9I is equal to, I'm taking this minus 4A inverse to the right hand side. So that will become, this minus will become plus, so 4A inverse. You need only A inverse. So from this, if you take your A inverse, it will become 1 divided by 4 into A square minus 6A plus 9I is equal to A inverse. Okay, so this is how you're finding out your A inverse with finding out your characteristic equation. Then, so proving that it is verified with your Cayley-Hamilton theorem, then you will find out your A inverse. How do you find out your A inverse? You will multiply your A inverse in that characteristic equation. Okay, the equation which you have taken for verification of your Cayley-Hamilton theorem, you will multiply your A inverse. After multiplying your A inverse, you segregate your A inverse and find out. Okay. Now you know the value of A square. You know the value of A 6 minus 6A. You have to find out 9 into your identity matrix divided by your 4. So how do you do that? So you will find out first what is your A square minus 6A plus 9I. So that is equal to, we will find out your A square value, we have got it here, 6 minus 5, 5 minus 5, 6 minus 5, 5 minus 5 and 6. Okay, and then I rub the A matrix. Very well. Okay, so A matrix, you multiply it with minus 6, so it will become, what is your A matrix? It is 2. So it will become minus 12, and then it will become plus 6, minus 6, plus 6, minus 12, plus 6, minus 6, plus 6, and minus 12. Just check whether I multiplied your minus 6 correctly. Okay, minus 6 in the given matrix. Then you've got your 9 into identity matrix. 9, 0, 0, 0, 9, 0, 0, 0. Okay, now what you'll have to do? You have to add 6 minus 12 plus 9. Find out. Write this A cube again next. So what do you get? You'll have 6 minus 12 and plus 9. Add it and 10. 3, 3 minus 5 plus 6, 0. That will be 1, 5 minus 6 and 0. Minus 1. Minus 5, 6, 0. Minus 5 and 6, 1. 6 minus 12 is minus 6 and 9. 6, so it is 3. Minus 5 and 6, it is 1. 5 minus 6 minus 1. Minus 5 and plus 1. Plus 6 is plus 1. 6 minus 12 and this. So this is the value of this term. A square minus 6a plus 9i. We have found out only that term. Okay, to find out your A inverse, what you'll have to do? To find out your A inverse, you have to divide the whole matrix divided by 4. Because this term only we have found out. It is 1 by 4 of this term. Okay, so to find out your A inverse is equal to 1 by 4 of the 3, 1 minus 1. So this is how you're finding out your A inverse. Any doubt you're getting? This is how you get your A inverse. So to find out your A inverse in the given matrix, you have to check whether it is getting satisfied with your Cayley-Hamilton theorem. After it is getting satisfied with your Cayley-Hamilton theorem, you will multiply A inverse with the equation that one, okay, with that equation 1. Okay, whichever we have proved for Cayley-Hamilton theorem. After multiplying it with A inverse, you're multiplying it with A inverse. A inverse is nothing but 1 by A. Okay, so you're multiplying and getting this equation. This equation you need to find out only for 4. You have to find out for your A inverse. So keeping this A inverse this side, find out what is that. Okay, so we have found out to be this. So first find out what matrix we are getting for this. We have found out. After finding out, divided by 4. Okay, because your A inverse is 1 by 4. Okay, write it down. If you're finished, tell me. We will go on to A power 4. You all finished?
1 minute, ma'am.
Yes. Okay. So this is how you're going to find out your A inverse. Next, we will go on to A power 4. Have you all finished? So for in this itself, in this concept itself, you tell me how you can find out A power 4. So to find out your A inverse, you have to multiply with A inverse I said. Similarly, for A power 4, how you can find?
A square into S.
A square into A square, okay, that's very good. That is little complicated. You have to multiply row wise into column. No, with this equation, how you can find out A power 4? We have found out that it is verifying your Cayley-Hamilton theorem. That equation, with that equation, we can find out your A power 4. It will be very easy. Instead of multiplying A square into A square, what you can do is, here we multiplied A inverse, isn't it? The same way, if you multiply with A, okay, A cube into A will become A power 4. Okay, directly, so from that equation, if you multiply with A, that will become A power 4. And from there, you want only A power 4. So you keep your A power 4 in your left hand side and find out your equation. Okay, so what I do is, here, the same thing, to find your A power 4, multiply this first equation by A power 4. A. I'm going to multiply it with A. So when I multiply it with A, what happens is, here is one A, I'm multiplying A and I'm multiplying A. So when I multiply it with A, what does it imply? It becomes A power 4 minus 6A cubed plus 9A square minus 4A equal to 0. Okay, in this we need to find only your A power 4. Okay, so A power 4 is equal to 6A cubed minus 9A square plus 4A. Okay, we already know what is your A cube, what is your A square, and what is your A. Just multiply it with your 6. Now 6 here for A cube. For A square, you will multiply minus 9. For A, you will multiply plus 4. So it will be 6 into A cube. First, I will write what is your A cube so that you can multiply it. Your A cube value was 22 minus 21, 21. Minus 21, 22, minus 21, 21, minus 21, 22. Okay. And then you can multiply this minus 9 inside. First, write what is your A square. Your A square was 6 minus 5, 5, minus 5, 6, minus 5, 5, minus 5, 6. Okay. Plus 4 into your given matrix was the given matrix 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2. Okay, this was your given matrix. Now multiply it inside. Now multiply it inside. You're getting A power 4 is equal to, when I multiply 6 into 22, you get 132. And 6 into 21 is 126 minus 120. So only 21 and 22 are there, so I can do it easily. So 22 into 6 is 132 and minus 126. 126 minus 126 and 132. Okay. Now I'm multiplying that minus also inside, and minus 9. So it will become minus 54. 9 minus into minus becomes positive 45 minus 45. If you have got space, you can do it in one line itself. Okay, don't come to the next line. Sometime you will go wrong. Okay, so better you can do it in one line itself. Then it is 45 minus into minus becomes plus minus 10 45 minus into minus plus then minus 45 plus 45 and then it is 54 minus 54. Do along with me and check your signs. Okay, if I have gone wrong, please tell me. And then we multiply this 4 inside, so it becomes 8 minus 4, 4 minus 4, 8 minus 4, 4 minus 4 and 8. Okay, now add it. So 132 minus 54 plus 8. So that is 140 minus 50 minus it is 86. Minus 126 plus 45 minus 4. You can use your calculator. Okay. So it is minus 130 plus 45, which will be minus 85. Do it with your calculator if you find it difficult and doing it manually. Okay. Then 126 minus 45 plus 4. So 126 plus 4 will become 130 minus 45, 85. Okay. So 132, sorry, minus 126 plus 45 minus 4. So it is minus 85. 132 minus 54 plus 8. So 140 minus 54, which will become 86. Minus 126 minus 4 minus 130 plus 45 minus 85. Do it. 130 minus 85. This is your A power. So this is how you're finding out your A power 4. Check whether you're getting this value. Yes, you're getting this value. Your addition, your sign, be very careful. If you go wrong in your signs, whole problem will go wrong. Okay. If you go wrong in your characteristic equation, the whole problem will go wrong. Okay. Be very careful in finding out your characteristic equation. Whenever you're finding out your characteristic equation, take time and do it. Okay. Realize what is your S1, what is your S2, what is your S3. Concentrate and do, you will definitely get it. Okay. So this is how you find out your A power 4. I gave you a homework problem. For that homework problem also, find out your A inverse and A power 4. The same way. Okay. I've told you how to find out. The same thing you can find out by A square into A square also. But it is a very lengthy procedure and you will go wrong. Okay. So what you have to do, you will find out your Cayley-Hamilton theorem, whether it is satisfied. After getting it satisfied, what you'll have to find? You'll find out your A inverse and your A power 4. Okay. Have you all written that side? I will drop this. Okay. And write the values of your A square, A cube. Okay. For the homework problem which I gave you. And check it with that. Okay. So your A square, first I will write your characteristic equation. Your characteristic equation was lambda cube minus 6 lambda square plus 7 lambda plus 2 equal to 0. Okay. So this was your characteristic equation, and you'll have to prove that a cube minus 6a square plus 7a plus 2I equal to 0. Okay. So you should prove that Cayley-Hamilton theorem is satisfied. So after getting that satisfied, okay, you have to find out your A inverse and A power 4. You'll find that and send it to me in my WhatsApp number. Now I will tell you the values of your A square. Mostly everyone had got it correct. 5, 0, 8, 2, 4, 5, 8, 0 and 13. This was your A square's value. Your A cube's value 21, 0, 34, 12, 8, 23, 34, 0, 5. Okay. This was your A square and A cube values. Okay. The students who have not got it, just check whether you're getting this value. Okay. So this was your A square and your A cube. Now for this problem, you will find out your A inverse and A power 4. Okay. For this problem, you will find out your A inverse and A power 4. Same way. So for that characteristic equation, you will take that, that you will take in that lambda, you will take it into A. That given matrix, you take it as your first equation. With that first equation, you multiply A inverse and get what is your A inverse. Similarly, multiply it with A to find out your A power 4. Find out and send it. Yes. If you've got any doubts, you ask me.